Hi everyone. Right now we have a charge plate, as you can see over here, connected to a fuel meter, and this fuel meter is connected to a software interface, as you can see on my bottom left. So through this software interface, it is connected to a laptop computer, and as you can see right now, we are trying to carry out the test in a test environment of 25.6% relative humidity. Under this low humidity, static generation is considered easily conducted. Static dissipation is also easily done in this environment. So the first step we're going to do right now is to charge up a piece of sample. We can see that this piece of sample has integrated on the charge plate. So the next step is to put a 1000 volt charge onto the piece of sample, and you could see over here that the sample has gone up to 1000 volt. Now when we release the charging source away from the sample, you could actually see that there are some charge still remaining on the piece of sample as well as the charge plate. So the next step is to find out how fast this piece of sample can discharge when we ground it. So we are going to put a piece of ground connector on the piece of sample to ground it, and over here on the graph you could see that the charges on the piece of sample as well as the plate has neutralized itself. So what we could do over here is to measure the amount of time it takes for the piece of sample to discharge itself from a high voltage to a low voltage, and thus deriving the decay time for it. Now this test can be conducted for multiple samples and in different relative humidity to find out the character of different materials.